Fair enough. Yes, the length of the blue line is y because it starts at 0. Yeah, so starts at 0, goes up to whatever the y coordinate is. If it was up at 11, then the length would be 11. This is just proving it. I'm not going to bother doing this. How would you find the area of the circle at the front?
Pi r squared.
Yep. And what is r?
Y.
And so how would you find the volume? Oh, sorry, how would you find the area?
Pi y squared.
Yes. How would you find the area of the first circle?
Find the radius.
Yep. And then?
And then, yeah, pi r squared.
And you could do that for all of the circles in between and then add them all up, and that would give you the volume.
Yeah.
The other way to do that is with integration. So
okay.
This proves where it comes from. It's basically the volume is pi y squared from B to A, where B and A are the two x coordinates. Don't have any practice questions. Let's see. Further maths. I have a worksheet that goes with it. I just want to see what the exam questions look like. Volumes of revolutions. There we go. That is 5.1. 5.1. Yep. So they proved it. Same thing. Okay. Example 1. Down the bottom. Make this bigger. Let's make this smaller. There we go. And let's make it look better. Yes. How do we do this one?
So would you just do like pi and then 9 minus x squared and then integrate?
Yeah. Between what and what?
0 and 3.
Yep. And I believe that's enough for your calculator. So I'm going to do simple calculator. We are integrating between 3 and 0. And it was pi y squared. Shift pi and y is equal to 9 minus x squared. And so 9 minus x squared, close bracket, all squared. Pi y squared, y is 9 minus x squared, so pi 9 minus x squared squared. And that's between 3 and 0 because the roots of that function will be 3 and minus 3. X squared is 9, x is plus or minus 3.
I got 407.15.
Okay, so that's what that looks like. I'm doing SD. That's what that looks like. Okay, let us see. Is that actually find the exact volume? Exact volume is 408 pi over 5, and the approximate volume is to a decimal. Any questions there?
No, it's not that difficult.
I agree. It's really not. This is exam question. Is this worth doing?
So is it always pi? times y squared.
Yep. What's the area of a circle?
Pi r squared.
Yep.
That's okay.
It's never not pi r squared.
So it doesn't matter like how much it's rotated.
It does, but it's rotated 360.
Okay.
It's rotated 2 pi. So how about this one?
So it's just 5 plus 4x minus x squared between 0 and the root of that.
Mm-hmm. And you know how to get the root of that?
Yeah.
Okay.
5, 0, and 5.
Okay. Oops. Oh, what am I doing? Minus 1. 5.
$250 pi.
So we believe 250 pi. That's the exact volume. Let me just check so we're not fooling ourselves. Come on, bookie. Allegedly. There we go. This is chapter 5, volumes of revolution. A. This thing. This was question 2, 250 pi. And they did a bunch of malarkey. Any questions about that?
No.
Okay, let's see if
If you
these...
like solved it properly, would you square it first or would you integrate it without like actually squaring it? Okay. Square it first, I think. Yeah.
Whatever's easier. I mean, you're just doing it numerically. You know.
Mhm.
No, I really wouldn't expand those square brackets first. Like,
Okay.
if you have to sub in 5, like it's so much easier to say minus 5 squared. That's just minus 25. I mean, it's so much easier to see this bookie. What is it doing? Let's see. This is a bit different. Oh, all right. How would you do this one?
You have to find out where it crosses the x-axis.
It doesn't cross the x-axis?
I mean, like the other root, the negative one. Oh, this one. Okay, I was thinking the next one. Wouldn't you just do the same, like just put 8 and 1 as the limits, and then 3 minus square root of x cubed squared?
Anything missing?
Oh, pi times.
Yeah. Let's just try it. We'll just do it all in one go. Third root. How do you do that? Is that shift square or something? Third root of x. Oh, press right and then close that bracket. Squared.
You still on call? There is no exact volume. I don't know why.
Answer equals okay. Now we're talking. So they kind of thwarted us a little bit. Okay, now we have to do it manually. So let's try this manually. How would we find the, if we were going through it?
You have to square it first, I guess. I feel like this would be okay to square because it only has 2 terms.
Okay.
So if you square that would be 9 minus 6 cube root x.
9 minus the 6th root of x.
Wait, wouldn't it be 6 times cube root x and not? Yeah, that plus the 6th root of x.
I don't think it works that way.
No.
That's the same as x to the 3rd.
Oh, right.
Because square root times square root would cancel out. It would just become 1.
So that's x to the 2/3.
I believe. So x to the 2/3.
Okay,
That
just
is
integrate that. Squared, yeah. But you could just write x to the 2/3, right?
well, you could also do this x to the 1/3, and you could have done x to the 1/3. You're the one who went down this road.
And then you just integrate that. So, well, pi times that.
Yeah. Integrate with respect to x.
Can you just take out the pi and then like multiply it later?
Yep.
So then you'd have 9x. Uh, 4.5x to the power of 4/3.
4.5x to the what, sorry?
To the power of 4/3.
Okay.
And then 3/5 x to the power of 5/3.
5/3. And that's all times pi?
Yeah.
Does that get any simpler, or is that it?
And then you have to substitute the limits. Like 1 and 8. And
Oh,
then,
yeah. I have to sub in 8 and 1 and take them away?
yeah.
All right. Okay. So x is 8.
I'm putting it into my calculator. Oh, but that won't work. I just realized.
Why won't it work?
Because it doesn't give you an exact answer.
I think it will. What is 8 to the power of a third?
2.
Yeah. And so 8 to the 4/3 would be 2 to the power 4. 8 to the 4th.
That's so 72 minus 72 plus 8 to the So the first bracket is just 19.2 pi.
Okay, so you're expanding the pi already?
Yeah.
Okay, 19.2 pi.
And then 9. And then minus 5.1 pi. Which gives you 14.1 pi. Is that an exact answer?
Looks exact to me. Pi is roughly 3 point something. 15, 30, 45. We said it's roughly 44. It's probably right. 14.1 shift pi equals. There we go. Is that the same number? Yep. Same thing. So you can use that to check your answer. 14.1 pi. Miraculous, isn't it? Hang on. question 3. 141 over 10 pi. Nothing wrong with 14.1 pi, but the convention is that you have to do it as it.
So why did the calculator not show that as an answer then?
Seems like it didn't like it. I mean, I did do the trick of answer,
And when I pressed like the F to D button, it didn't work. Yeah, that one.
Huh. So yeah, you're using the graphical, are you?
Yeah.
Didn't work in either. There you go. You got the right answer. Any questions about that?
No.
Right. This might be easier. Who knows? But you got the right answer. What I would have done right from the start is x to the third.
Yeah.
And used x to the third. Also, I wouldn't have mixed decimals and fractions. I mean, your thing worked out in the end. So you wanted the integral between 8 and 1 pi y squared. So that's squared x to the third squared 9 minus that is 3x to the third minus 6x to the maybe I would have gotten it wrong. What if there were two brackets with the same thing? So that's going to be plus x to the 2/3. Am I crazy? Yeah. Or am I crazy? Is that to the 1/3?
Yeah, that is.
Yeah, so that's that. So then you had to do pi times 9 minus 6x to the third plus x to the 2/3 with respect to x. You said you can take the pi out and just deal with that at the end. And so you have 9 minus 6x to the third plus x to the 2/3 with respect to x. And you just go through it the normal way. 9x, that's going to be minus 6 over 4 over 3, x to the 4 over 3 plus 3 over 5 x to the 5 over 3. What I might do, and we needed that between 8 and 1. What I might do is do the 8, then do the 1, and then just at the very end times your answer by pi. Like stick a pi at the end. That's the only way. Other than that, I mean, you got the right answer. I'm happy enough. Let us see. Is question 4 any different? Question 4 any different?
Not really.
No. I think what I would do for all of them is start with the try integrating it. Do you know what this root will be?
X is would it be -2?
Yep, -2. I have an idea. I shouldn't have deleted my other one. Oh, I can get it back. Pi and then y squared square root of x plus 2. Close that bracket. Oh, it's taking its time with this one. Okay, so this one just worked. I have an idea for the previous one though. This one, I want to try something. I'm going to delete pi. Oh, look at that, Amogha. I did it without pi and I got 14.1. So then I would just do 14.1 shift pi and get an exact answer like that.
That's a good idea. Well, my second, like the root x plus 2 one, it didn't work as an exact answer either.
Take away
But
the pi.
you 5 1/3. So, like that one's like I can tell what it is. Yeah, 16/3.
Okay. Let's see. Question 5. The region is rotated. Find the volume of solid revolution. I think you okay for this?
Yeah.
Okay. Question 6. They're making it more weird, but you would have to find the root.
Mm-hmm.
How would you find the root?
Just make y equal to 0 and then solve.
Yeah. Go on, solve it. How would you solve that?
When y is equal to 0. Oh, I got x is equal to 1.
I'm sure it is. And then, let's see. So that will be if x is 1. Yep, x is 1. I just subbed it in to check the answer. Between 1 and 6, pi times y squared. Yeah, and just calculator can do the rest, I think, with that one. Mm-hmm. Yeah, everything okay there?
Yeah.
Let's see what question 8 looks like. Oh, that's a bit weird. The curve shown in this diagram. A is between 0 and 2. Find the value of A. This is more like it. Working in reverse. They give us the answer. We have to work out the question, the root.
Okay.
Or not,
so
kind of the root.
Pi. Okay, well, so it's between A and 2, like the integration. So you can put in like 2 and A as limits, and then pi y squared. So
what is y?
X, and then square root 4 minus x squared. So if you square that, you just have x squared, and then 4 minus x squared in brackets.
Don't
right?
care. Don't know, don't care. How do we do it?
You like basically do it like a normal integration, and then at the end you make it equal to 657 pi over 160.
What type of tutor do you have, Amogha?
Huh?
What type of tutor do you have?
I don't know.
You've got the best of the best. You've got the top gun. Do I try it with pi? Yeah, I'm trying it with pi. Do I put the pi in the integral?
The calculator.
Let's see. Shift. Integral. Up the top is 2. What do we call the bottom one?
X.
We sure do, kiddo. Let's try it. Okay, bracket x. You're a nerd. You're going to expand that bracket. I'm doing even less work than that. Hang on. Will this work? Yeah, this might just work even. So x root 4 minus x squared. Close that bracket. So that means x. Yeah, and that whole thing's squared. We go right until we're after the dx equals fraction 657 shift pi.
I don't do it equals.
What, on graphical is it?
Yeah.
I'm sure I can figure it out. 1 sec.
I can't. Oh, I can.
Okay, graphical calculator time. How is there no equal sign? There has to be an equal sign. How do you solve anything?
There's a button that says EXE.
It's over that, is it?
Hmm?
I don't know. Hang on. Equals is a shift decimal point.
Oh, yeah.
Run matrix.
Wait, what do you put as equals?
Where is it? 657 pi over 160.
657. Non-real error.
Press exit or something. Are you in solver mode? Are you in run matrix?
No, just on like the normal math. Maybe that's what.
Solve n. What is this one? We could try putting. So you did integral. Is that math? And then right for integral? Yeah. So we are solving this thing between 2 and x. We are doing in a bracket x times the square root. Where's square root? Shift that one. Square root 4 minus x squared. The whole thing squared. Yep. So that whole thing, the solution to that is equal to shift equal to fraction 657. How do you do pi? Shift that over 160. I then have to close my bracket. It should be blue. It is blue. Don't say non-real. Oh, work hard, calculator. More solutions may exist. That's what I got. Okay, which one is correct? Because my one, I got 0.5 in my other calculator.
This one is definitely wrong because A is less than 2.
Yeah. I think as well it might be, I should probably use, like I don't quite know, I should probably use the solver, like this equation thing, F3 for solver, and just put an equation up here. That's what I should do. And you can use A for X. I think what might be the problem is with this one, it uses X in the function and X as the unknown. And I think that's what it's doing. Other than that, I think you know how to do it. It's just long and laborious. You can do it if you want, or you think you get the idea?
No, I know how to do it.
Okay, let me just check. So that was question 8. Question 8, A is equal to a half. And just use your simple calculator. A equals a half. Too easy. Too easy. Okay. Yes. So what do you give yourself for that previous one? X a half or tick?
I tick.
Grant. Okay. Next one. If it is a volume of solid of revolution about the y-axis, same idea. What's the radius of that circle?
X.
Yep. And so instead of it being pi r squared, it is pi x squared.
Oh, okay.
Difficult stuff. Okay, let's do one. How about this?
So it's basically the same, but it's just x squared instead of y.
Yep.
Okay.
We'll do one, see how it goes.
So you have to make x the subject. So that would be y squared plus 1 is equal to x.
Okay.
And then you just do pi y squared plus 1.
Do it.
And with the limits 3 and 1.
Yeah, let's leave pi on the outside. through 1 and x squared, and so it is y squared plus 1 squared with respect to y.
Yeah.
But with the calculator, I just have to use x because that's the only letter this one has. In a bracket, x squared plus 1, that whole thing squared, between 1 and 3, pi on the outside, shift pi. Tell me when you have an answer for that.
I'm almost done.
Are you doing it by hand?
Yeah, it's not that long.
All right.
I'm done. 2023 over 30 pi. Oh, it's the same. It's just times two.
It simplifies down to that.
Yeah.
Yep. That's just a fraction in its simplest form. Yes, great. Any questions there?
No. So if you wrote it not in its simplest form, would you get it wrong?
No. At the end of the exam question, it will say OE, meaning or equivalent.
Okay.
Let's see. First one is easy peasy because it gave it to you in the form of x equals.
Yeah, that's easy. That one as well.
Second one, yeah, and it's giving you the bounds 9 and 4. 4 and 1 with x equals. I mean, it's just the same. See, they're not really anticipating that you know how to do it with your calculator. That's the thing. All right. How do we start 5?
Find the minimum point.
Yep.
So you have to differentiate it.
You could. Hang on, kiddo. I'm going to put into my calculator.
Calculator, yeah.
Yeah, to solve it.
It's not working.
There are no roots.
Oh.
However, press equals, imaginary root, press equals, imaginary root, press equals. Minimum is when x is 0.
You could just graph it on the calculator and then.
What does it say? What does it say?
5.
Yeah. You don't have this calculator at all. You just have the graphical, is it?
Yeah, I just have one.
Yeah, graph it.
I could just graph it, and it says 0, 5.
Yeah. Graphical solve, minimum. And so, what is the...
Or 10 and 5. And then you have to rearrange to make x the subject, so... So x is equal to the square root of y minus 5 over 2.
And what is everything in the square root?
Yeah.
Yep. Y minus 5 over 2.
Square that. So...
Oh,
yeah. Square that one first, because you just get rid of the square root.
So y minus 5 over 2. I think you'd be fine for the rest of that.
Yeah, I can.
Grant. So the only difference there was they didn't give you the bounds.
Yeah, the minimum point.
Let's see. Question 6 is between 9 and 1. X. It's given as like y equals. Show that the equation can be written as x squared is equal to that. Hang on, is there anything weird about that? Making x squared the subject. Yeah. Okay. How would you do part A for this one?
I would do y minus 1 is equal to x squared minus 2x, and then why would you get 2 root y?
Stop looking at the answer. Make x the subject.
Oh, it's because you have to factorize out x squared. I'm not really sure how to do it.
So if you were to factorize this, I think you get x minus 1, x minus 1. Is that right? It's not very important.
Yeah. No, yeah, you do get it.
So the problem is you've still got two x's. There is one way that you can go from having this to just one x, and that is by completing the square.
I don't like completing the square.
Nobody does.
So, x. X minus 1?
Yes, and actually this is a very, very special case because it was the same bracket twice, and so actually that would just be x minus 1 squared.
Yes.
Alright, make x the subject.
Square root.
Yep.
And then add 1 to both sides.
Yeah. So x is 1 plus square root of y minus 1. Is that what they asked for?
Nope.
Oh, x squared equals.
Oh, okay. So you just square it again at the end.
X squared equals 1 plus root y minus 1. 2 mark question. I'm just going to say x squared equals the thing they told me. 2
but
root y plus
1.
It's
not going to be that once you square it.
I think it will be. 1 squared is 1. This squared is y minus 1. So that's where we get our y. And then 2 times 1 times that.
Oh, yeah. 2ab. I forgot about that bit.
Yeah. So she works out. And then question B.
So you already know what x squared is, so you just have to integrate the y plus 2 root y plus 1 between 1 and 9. Yeah.
Y plus 2. Let's say
Y have half.
Yeah, and then you just go from there. Grand. Any questions about that one?
No.
Okay, let's see. Oh, this is weird. Don't know if it's any harder. Y cubed. Might make more sense. Okay, how do we do this?
So y cubed minus 2y is equal to 4 minus x squared.
Okay.
And then would you complete the square?
You can.
I mean, because factorizing it wouldn't help.
I think it's similar to the previous one. I think factorizing might help.
Because it's difference of 2 squares, so it'd be 2 minus x, 2 plus x.
Yes. So in that case, completing the square.
Cool.
And if it helps, which it probably will, but a
Take
minus
the square.
Like that.
Okay. I don't really know how to complete the square for this one.
B over 2. Oh, what are we doing? Just make x squared the subject.
That's really easy.
X squared equals
4 minus y cubed plus 2y.
cubed
Yeah, that's
plus 2y. There we go. So pi.
so if you can't make x the subject, then you have to make x squared. Okay.
What are the limits?
-2 and 2.
Wrong.
Oh, 0 and 2. Sorry.
Yes. That's the trick. That's the trick with that question. Grand. Any questions about that one?
No, I understood it.
Let's see this one. That's between 1 and 4. Is this one worth doing?
Which one? Number 8.
Mm-hmm.
I mean, it looks similar to the other ones.
I think
you just have to rearrange again to make x the subject.
Make x the subject, make it x squared, and then...
Yeah.
Okay, what do you give yourself there?
Tick.
Okay, adding and subtracting volumes. A cylinder is pi r squared h. A cone is a third pi r squared h. Okay. This malarkey. This isn't... Oh, it is. I spoke too soon. Alright. Why are they doing this to me? What is this one?
It's the point of intersection, so you just need to x cubed plus 2 is equal to 5 minus 2x, and then solve it for x.
I think a verify question, I think I would just sub in 1 for x and get 3 for y. Sub in 1 for x, get 3 for y. Yeah.
Okay. So 1 cubed plus 2 is equal to 3, and then 5 minus 2 is equal to 3.
Okay. Where would it be?
Don't know.
I have my thoughts. What if we did just the red line from there to there? Volume of solid of revolution.
Would that be... Oh, that would just be like pi y squared.
And what is y for that one?
In 0 and 2.5.
2.5. And y is what?
5 minus 2x.
5 minus 2x. So that'll be squared. That's with respect to x. That would give us that total volume.
Yeah.
How would we get the...
curve a bit.
That would give us the shaded and the unshaded regions.
Oh, and then you just do the cubic one, and then you can subtract them. Right?
Will that work?
I don't know.
So that's the total.
Oh, you can't do the cubic one because it doesn't go all the way to x. Wait, no, you can. But it wouldn't be the right view.
It's not what I thought. I think if we draw a line there, I think if we do the cubic from 0 to 1 and then add the line from 1 to 3, will that work?
I don't know. Why would the line be till 3?
Oh, sorry, 2.5.
Okay.
So
wait, the line from 1 to 2.5 and then the cubic from 0 to 1.
Yes, Am I right? So that would be 0 to 1 of that one squared. And then plus the other one. 2.5 to 1. 5 minus 2x squared with respect to x. Do we calculator it?
I think so.
All right. I'm going to do it without pi and just put pi in at the end.
Yeah, pi just complicates everything.
Cubed plus 2 squared. And I'm glad that I didn't spend lots of time doing the other stuff manually. Okay, so the first one is 36 over 7 pi, I think.
Yeah, that's what I got.
Okay. And then what's the second?
Nine over 2 pi.
Same. And so, what do you get?
135 over 14 pi.
Common denominator 14. Oh, let's hope this is right. 135 over 14 pi. Yes. So, what did they? Same idea. So you just cut it into two parts. It was that part plus that part. First one from 1 to 0. Second one from 2.5 to 1. This was the cubic. This was the straight line. Any questions about that?
No, it's not that.
Yeah, you have to kind of visualize it a bit.
Yeah.
Oh, why did they say more complicated? That's the last thing I want to see. All right. How about this one?
Literally no idea.
No idea.
Yeah.
If you have no
How
idea.
do you find one above the curve? Like, how do you find the area above it?
You don't. You do not. I have an idea.
Oh, wait, you just find the area, like, below the red one.
Yeah.
And then you find, like, the area below the black one from the point of intersection to 1. And then if you subtract them, this should be the right answer.
Boom.
Oh, that was right. Okay. So 1 to 0 pi root x squared.
You don't have the point of intersection yet.
I know, I'm doing the red one first.
You cheeked us, man. Okay.
Because that's the one you're subtracting from. So
pi on the outside from 1 to 0
root x squared, which is just x. Minus point of intersection, which I need to find.
How do you find the point of intersection?
You make them equal to one another.
Yep.
And then you solve for x.
Yep. Root x is equal to 1 over 8x.
Oh, wait, I should have squared both sides first.
You should have. Have I called you a nerd girl enough?
No.
Shift solve. Entirely in the calculator. I used to work hard. Those days are over.
It's, wait. Oh, it's 1/4.
Oh, that's not the right calculator thing. You betrayed me, calculator. There we go.
I could have done it wrong. I don't know.
No, that's right. I got the same thing. 0.25.
And then y is half. There we go. Oh, you don't need y, right? Never mind.
And you're done. Just put that in.
Yeah. Calculator.
Yeah.
One I will actually use the calculator for.
So this one is going to be probably just 1, the first one.
Yeah, it's a half.
Oh, there you go. Serves me right. So that's a half pi.
And then you know the second one?
Yeah.
I just got a decimal as the answer, like it doesn't have a fraction.
Like a thing going forever, is it? There's nothing wrong with that.
No, yeah, I got that.
So
Exact answer.
well, there aren't. That is exact. It's a terminating decimal. If it helps you, press answer. Oh, no, there you go. Well, whatever. How many times is that? 1. So times it by 1, 2, 3, 4, 5, 6. 1 with 6 zeros on the bottom, and then that number on the top. If you prefer, but it's basically. Oh, I see.
But when you subtract it, you get an answer, an exact answer, somehow.
0.04. So a half minus that, is it? 6.75.
I did half pi minus, but.
And what do you get?
29 over 64 pi.
29 over 64 pi. Looks fine to me. Let's see, 29.
1.4.
Okay. Hang on. That's what I should have done. 29 over 64 pi. 29 over 64 pi. 27 over 64, was it?
I don't know why they got that.
27 over 64 pi. Hang on. Did we just type something in wrong?
I don't think.
0.046875 and 0. Let me just check they're working out. I don't know. That's 15 pi over 32 is that one.
First one.
So
I got a half. They got less than a half somehow.
15 over 30 is a half.
Wait, they got that for the second one. They got like the one between 1 and 0.25. What? Oh, I don't know what they did.
Oh, they didn't do our mistake. It's the first one isn't between 1 and 0. What should it be between?
Is it not between 1 and 0?
No. It's between 1 and a quarter.
Okay.
Yeah.
But surely even if you do it between 1 and 0,
no.
when you do the second one, that bit just gets cancelled, like when you subtract them.
Well, we didn't do. No, because we have an extra little bit.
Oh, okay.
Yeah.
That makes sense.
So the first one should be between. Oh, I didn't actually. Oh, I just have the same thing twice. Oh, here it is. This one should be between 1 and a quarter.
Okay. Yeah, then you get 15 over 32.
15 over 32.
Which gives you 27 over 64 pi.
Okay. Any questions there?
No, you just have to be careful.
Yeah, you just have to do.
All lines, probably.
They weren't lying when they said more complicated. Okay, let's see. Is this one worth doing?
Oh god. That one isn't super bad. I think you just add them together.
Yeah, I think that's the simpler type. Let's see, 3. I think 3 is worth doing.
Really? Okay.
Oops. Don't wait for me. Okay, how do we do this?
So you have to do the curve between, I don't know if you do it between A and B or...
So let me just do that straight down.
So yeah, between A and B.
Yep.
And then the line also between A and B. And then just subtract them.
Yeah. Go on, let's try it. And they said A is 2, 4.
Yeah, and B is something else, but X is 4. I know that much. Yeah, so the first one is just 4, like 4 into the limits, and then you have minus half x squared x minus 4 squared. It's the curve, right?
Yeah. Yep.
Calculator.
Yeah, big time.
I'm not even going to try. Then the second one, also 2 and 4, and 2x minus 8.
Well done. And are you sure that these are 2 and 4? So A is 2, yeah. And B, how do you know that that's 4? When Y is 0, yep. Oops.
Why is it minus pi?
No, I'm getting ahead of my skis. Whatever it's called, over my skis. You bring 0 to 2x minus 8 all squared. Was that it? No, 8 minus 2x, I think it is.
No, isn't it 2x minus... Oh, that would give you minus y. Never mind. So it is 8 minus 2x.
Squared. Respect to x with respect to x.
916 over 35 pi.
Okay.
Why is that like crossed out?
Why is what, sorry?
Like that thing in that box that says problem solving, why is it all like crossed out?
Because it tells you how to get the answer. It tells you that you should you should use subtraction. I'm getting 32 over 3. Did you use pi, was it?
I got for that. Oh, I didn't square it. Never mind. Yeah, it's wrong answer. $2,048 over 105 pi.
2,048 over?
Oh, 105.
105. This is question 3, exam question for is it section B or section C? I don't know. I think it's in section C now. This is question 3. 2048 over 105 pi. Well done. What do you give yourself for that stuff, Amogha?
Tick. It's not that complicated.
Great. I agree. There aren't many tutors who know these calculator tricks, I tell you that. Let me just do a quick look. Let's see. If I go back to this thing, modeling with volumes of revolution is just applying it. So applying it to real world stuff. And that's probably the last thing. Yeah. So any topic in particular you want to do next time?
Some further maths topic. I don't know what the topics are, but
You can do complex numbers if you want.
okay. I know a bit. I know That's it.
You need to know a little more than that. Or if there's anything else, you can let me know. Any question? Say it again.
Complex numbers is fine.
Oh, is it fine?
Yeah, I'll do it.
I'll
do it next week.
Hang on, let's find something.
No, I'll do it next week. It's fine.
Oh, okay. Sorry, I thought you meant you didn't. No. Any questions for me in general?
No.
All right. Well done, Amogha. You did great. I look forward to chatting again next week. Have a good week. Goodbye.
Thank you. Bye.